In this video, we will be recapping what we learned in our first week of Statics 202, which talks about some basic vector formulation, vector operations, such as vector addition, vector decomposition, and just understanding basics of geometry that are needed to understand basic 2D questions relating to force and force systems. So to start things off, we are going to do a little bit of a recap for some trigonometry rules. First, we're going to talk about sine law, and these are going to help you to decompose different forces, right? So this is good when you don't have a y or an x-based axis system. Say if you had different axes that it was acting on, you wanted to find those specific components. Sine law and cosine law are going to be helping you a lot for that. Sine law works for all triangles. So I'm going to label angles. So you'll see why I've color-coded this in just a second. So sine law states that if you have sine sine of your angle over the length that is directly opposite of that angle, the ratio is equal to each sequential one. So if you have sine beta, right, we go across to length b is equal to sine gamma over c. In that same way, a is equal to sine alpha, b over sine beta, which is equal to c over sine gamma. So cosine law is great to use when you have two sides. Let me pause. When you have two sides and one angle, or when you have two angles and one side. So now we're going to talk about cosine law, nice and quick. Same kind of thing. So I'm going to label these again. Let's see. So we use cosine law when we are given three sides. Oops. If we're given three sides or two sides and an angle. And cosine law is as follows. So if we were to start with c, that would be c squared is equal to a squared plus, that's our length, a squared plus length b squared minus 2ab cos of the angle that is across from c, which is gamma. So let's do it for b. So if we have b squared is equal to c squared plus a squared minus 2ca cos beta. Lastly, a squared is equal to b squared plus c squared minus 2bc cos alpha. Right, so both of these laws are going to be helpful when we are breaking down our vectors. So there's two different methods to use when we're talking about vector addition. So I'm going to start us off with the triangular method. So if we had two vectors which originate out of the same point, what we're going to need to do for our triangle, first step is arrange tip to tail. So we have to move these around a bit. So if we have a red one here, that means we'd have to take our blue one and slide it up to meet the red one. So the tail is aligned at the tip of the first one. So if we treat red as our first one, here's our second one. Blue is our second one. Now we're going to draw our resultant vector. So when we draw our resultant vector, we want to match tails and tips. So there's one open tip here, one open tail here, so we're going to match it up and go tail to tip. Right? And green is our resultant. So now if we had a quadrilateral way of solving it, this works easier when I illustrate it in a Cartesian plane. So let's say we have our red and blue again. What we want to do this time, we're going to start with our second force, and at the tip of our first one, I'm going to draw a line that is parallel. So draw parallel line at other vector tip. And now we want to do the same thing. Draw a line parallel, starting from the other vector's tip, and we want to connect it. So now we have a quadrilateral, and what we're going to do, we are going to take our resultant force, starting from origin to intersecting corner, is our resultant force. Right, so different ways to go about solving that. If that is not really your style, you can do vector decomposition, but this only works if you have x, y basis, right? So if you have a vector, you can always break it down into x and y components. So I'll draw that better. Right, this is also another option you could always use. So just make sure all your directions are kept the same way. So if you wanted to do, so you'd have to find the sum of the x directions first, which from our red one would be f1 times cos theta. For our blue one, we can call this phi instead. So that is in our positive x direction. And this would be plus because we also follow a positive x direction in our x component for f2, which would be cos phi. Same thing for our y components. We have the positive y direction for f1, so that'd be f1 sine theta. And that would be minus, since we're pointing down, f2 sine phi. So then what we need to do, in order to find our resultant, we need to take the magnitude of both of these. So that means we find the hypotenuse. So that would be our net x squared plus our net y squared. This technique is a lot easier for me when I'm using multiple. So say if we had more than two, say if we added like a third one going this way, right? I think this is a lot easier to solve. But again, this is only valid for an xy basis. It only makes sense if we use that. So otherwise, I think quadrilateral is honestly your best bet if you have non-xy bases. So I'll explain what that means in this example. Okay, so we want to resolve forces 1 and forces 2 along their u and v axes, right? So this is going to be a little tricky because we need to decompose along an axis that isn't our y or x. So how I would do the first problem, I'm going to draw out F1. So what you can imagine is, yeah, you can imagine this as a quadrilateral. So I'm going to use this orange right here. So let's draw a parallel line that will intersect with our point of our vector arrow, and that will represent our v-axis. And then along our u-axis, let's draw another parallel line that will meet the tip of our vector, right? So that gives us our quadrilateral where it meets corner to corner between our two intersections. So I'm going to draw that out over here again. And let's just draw one upper half. So here's our fuchsia. Here is our F1. And we know this to be 30, and this length is 4. So we want to find what our x and y, our u and v components are. So this is u and v. And what do we have? We have one angle and we have one length, all right? So there's a couple things we need to solve for. There's a couple things that we need to fill in. So we can fill in our angle between, because we don't have quite enough to use sine or cosine law yet. So here's some information that we're given. We know that between our u and v axes, that we have an angle of 30 plus 45. 30 plus 45 is 75. So between our fuchsia and orange is going to be the same as here between our fuchsia and orange in this triangle. So we know that is 75 degrees. And that means we can fill in our last angle here because we know that triangles have a sum of 180 degrees. So if we subtract 30 and subtract 75, that will give us 75 degrees. And that goes here. Okay, so now we can use sine law to solve this. So let's start with our u. So sine 75, right, because this is across from u, right? I'm actually going to color code that. Let's color code that. Is going to be equal to, and we have our given. So as a rule of thumb, I like to always use the given one, even if you have more than you need. And then that would be sine 75, which is across from 4. So we want to solve for that u right there. So then that will give us u is equal to, so we have sine 75 divided by 4, sine 75 divided by this answer, and u is equal to 4. No, it's not. Okay, hold on, something went weird. Okay, I realized where I screwed up with this question. So we need to consider our whole quadrilateral first. Okay, so let's take this from the top. Okay, so what do we know? We know this is 30, 45, so therefore this is 45, and this is 30. There we go. Okay, now we can solve for this top and bottom corners. So we know that 180 minus 30 minus 45 is going to give us our last angle. So 180 minus 45 minus 30 is 105. This is 105 here. So now for problem 1, if we just take a look at what we're given, let's solve for our u component here. So u is equal to sine, what's opposite? 45 equals, then we have 4 here, so this is 4, as our force, over sine 105. And this should be u equals, there we go, 2.93 newtons. There you go, that's much better. Let's go again for F1. So V is across from sine 30, and that's equal to 4 over sine 105. So that means V is equal to, let's notate these better. So that's 4 times sine 30 divided by sine 105, and that's 2.07. 7 newtons. Okay, that was much better. Okay, so now let's do the same thing with F2. So F2, I'm going to take one of our, so we're going to do U this time, so I'm doing U in blue, starting from the tip. We're going to draw a line parallel starting from the tip of our force. Then for U, draw it like this. And just extend those. So here is what our quadrilateral looks like. I'm going to draw it like this again, so it's easier to see. And then here is our 6 newtons. 6. Okay, what do we know? We know that the angle between our V, our force, we know that is 30 degrees. So that means this is also 30 degrees. We know that there's 45 over here to our x-axis. So that means this will be this angle right here. So we know all of this has to be 90 degrees, right? So if you do 90 minus 45 minus 30, that gives you 15 degrees from our y-axis. This is 30. Actually, no, hold on. Better way to do this. From here, we know 30 is also this measure here. So that means the angle is going to be 15 plus 90 minus 30. So what would that angle be? It's going to be, so we have 90 plus 15 minus 30, and that's 75 degrees here, which is 75 here. And then for our last angle, we'll solve 180 minus 75 minus 30, and that also makes this 75. Okay, so let's see if we did our geometry right. Let's go ahead and solve for u. Opposite of u is sine 30, which is equal to 6 this time. Across from 6 is 75. So 6 sine 30 divided by sine 75, 3.1. There you go. 3.11. And the reason that there's a negative sign here is because it will be pointing in the negative u direction. Right? Because if we do our vector addition, do tip to tail with our triangle, right? So that will point negative u direction and negative v direction. So let's do our v. And that's just going to equal 6 newtons. There we go. Okay, so that's step 1 done. And now we want to solve their x and y components. So for f1, it's nice and easy because f1 only has an x component, so it's just going to equal that for its x component, and f1y equals 0 newtons. For f2y, the angle that it makes with the axis, the x-axis, is 45 plus 30, which is 75. So let's do that. And that's our negative y direction. Right? Yes. So that's 6 sine 75. It's equal to 6 cos 5, 1.55 newtons. And this is negative 5.80 newtons. Okay, and problem 3. Draw the parallel showing the resultant force of F1 and F2. So if we were to use F1 here, F2 is kind of like right here. You can just use the triangle rule for this one, since we only have two forces. So that means it'd be pointing at an angle this way. Does it want direction? It does want direction. Okay, so it wants magnitude and direction of this. So let's start with our magnitude. Let's get our sum of our fx's, which is equal to 4 from 1, and 1.5 from 2, which equals 5.55 newtons. 0 minus 5.8 is negative 5.80. Then our resultant magnitude is 5.55 squared plus negative 5.80 squared. And that gives 8.03 newtons. Our direction is a little different. So if we were to imagine this in a Cartesian plane with this as the origin, that means this would be pointing in that direction. So we'd have to get our measurement of this angle plus that one. Right? So let's start with this angle here. So our angle is tan inverse of our opposite over adjacent. So our opposite is our 5.5. It's our x. Then our y is negative. Well, let's not use negative. Let's just use its value, 5.80, which equals and this is 43 degrees. Then we have to add our phi. We know that to be 90 degrees. So then our total is 43 plus 73 plus 90 degrees equals 133.738 degrees. Let's check to see if we're right. Oh, we are not right. Oh, because you know why we're not right? It's because we didn't use tip to tail. So let's reevaluate. So both these come out of the same point, right? But we want to slide that over to meet the red one's tail. There we go. So then this points like that. Right, so my mistake is going to point so that it's in quadrant 4, like such. Instead, that's going to be 360 minus this. So opposite is going to be 58 now. 5.8. That's our adjacent. So that's 46 degrees, 46.261. And we're going to take 360 and subtract that to get our angle measured counterclockwise. So 360 minus answer, and that's 313 degrees. Which makes more sense. 313.73 degrees. Okay, so that covers our first example problem. I'm going to start a new video to talk about some more examples. So in this video, we covered just some basic math that you'll need to break down geometry of vectors, including sine law, cosine law, vector addition using a triangle and quadrilateral method, and using decomposition. All right, see you in the next video.